Vacuum tube guitar amplifiers have many different sonic personalities, but all have basic similarities. For example, all have high voltage DC power supplies that use electrolytic capacitors for filtering DC ripple, which occurs when AC wall current is rectified to DC. All have preamp circuits. Most all preamp tubes are cathode biased and use electrolytic bypass capacitors that eventually will need replacing. All have output tubes that are either cathode biased or fixed biased. These will eventually need replacement. All have volume controls. Some have tone controls. Some have reverb, or vibrato, or tremolo. In this video, we'll take a generic tube guitar amplifier and restore it to original condition. The same principles used for restoring this particular amp would apply to other vacuum tube guitar amplifiers. Here's an example of a blackface Fender amp. Most of the blackface amplifiers use the same circuitry, the only difference being the output transformers, power supplies, and of course the speaker configuration. This particular one is a deluxe reverb, and the board, the preamp circuitry, which is right here, is the common board for most of the blackface amps. Before we get started working on the actual amp, it'd be a good idea to discharge all the electricity in the amp. The easy way to do that is to make sure the amp is unplugged. Of course, this one's not plugged in, but we want to make sure it's not plugged. And you clip one end of your test lead to the chassis, the other end to pin 1 of any preamp tube, and make sure your switches are in this position. This will discharge all electricity in the amp in a matter of about 20 seconds. Now that the amp is safe to handle, let's take a visual inspection of the amp. We can see right here that the grounding bus is corroded. This grounding bus is made out of brass, and all of the pots and jacks and so forth connect to that grounding bus, and that's how they make their ground connection. So it's very important that we have a good connection here. These knobs need to be taken off, the pots need to be taken off, and the grounding bus needs to be cleaned, as well as the faces of the pots and jacks. Most Fender amps have a mistake in the output stage wiring, and we can check this one for that. It's the way the filament is hooked up from one output tube to the next. Ordinarily, your output tubes would be hum canceling if they're hooked up correctly. However, the people that wired some of these early amps weren't paying attention to that being a concern. The filament starts at the pilot lamp, and it's the pair of green wires that goes from the pilot lamp to the first output tube, to the next output tube, and then to each preamp tube. In this particular amp, it's wired with green wire. You can see pin 7 here, and if you look real close and follow the wire and look at the exact wire, you can see that it ends up terminating over here on pin 2, which is exactly what we don't want. We want 7 to terminate on 7 and we want 2 to terminate on 2. Now let's turn the amp over and check out the filter caps. You notice there's a pan here. Most Fender amps have the pan. We're just going to unscrew the screws that fasten down the cap pan here. And take a visual inspection of these. Look at here. All of these are bad. You can see the bubbles on each one of these caps. This indicates that they're bad and should be replaced. In a worst case scenario, the bubbles will actually burst and some of the chemicals will be oozing out of the cap itself. These caps all have a polarity, and in this particular amp, all of the positive ones are on one side and all of the negative ones are on the other side. These look like original caps, and they're probably, I don't know, over 30 years old. Another thing we want to do is we want to take a look, make sure we've got all the correct tubes. All of these have preamp tube covers, which are the bayonet style. You twist them off. There should be 2 12A T7s and the rest 12A X7s in this type of amp. This phase inverter tube is a 12A T7, and your reverb driver tube is also a 12A T7. Yep, 12AX7, wrong type of tube. And then these two are, that's a 7025, which is a 12AX7, same thing. 12AX7, that one's fine. The other 12AT is going to be in the phase inverter tube, which is going to be the one next to the power tubes. This one is definitely a 12AT. This tube is your vibrato tube, which is a 12AX, and this is correct. And we've got a 12AX7 there. So what we want to do before we put these tubes back in is we want to straighten the pins. The pin straightener is made out of metal. It's a block of metal, and you can put your tube into the pin holes, and it will make sure that the pins are nice and straight. You just basically just push them in there like that. See here? It's going to make it a lot easier to get the tubes back in later on, and you run less chance of bending a pin in a socket or damaging a socket for that matter. Next thing we're going to want to do is spray out all of the sockets with some deoxit. This will clean any corrosion out of the sockets. We'll go ahead and do the output tube sockets and the rectifier tube socket as well. And we want to put the tubes back in. We've got a 12AT7 here. We'll put it in the reverb driver slot, which is right here. Next we have a 7025. We'll put that in the first gain stage. Of the normal channel. Here's another 7025. This one can go in the first gain stage of the reverb channel. Here's another 12AX7 style. We'll use it as the reverb recovery. And another 12AX7 for the vibrata. And we're going to need another 12AT7. This is a 12AX7. And I happen to have one right here. This one is a JAN, which stands for Joint Army Navy 12AT7WC. New old stock, made by Philips. And we'll use this for the phase inverter, which will be right here. Another little tidbit is when replacing tubes, you don't have to necessarily buy a whole new set of tubes. Some players don't use the normal channel, just any tube that'll work will be fine in that channel if you're not going to use the channel anyway. Also, your vibrato tube does not pass audio signal. If the tube works at all, it will work well enough to oscillate, which is all you need in your vibrato tube. So these are things to consider when replacing the tubes in an amp. Next, we're going to put new output tubes into the amp. And I have a pair of them right here. These are November 1951 manufacture, new old stock Vissot 6V6 GTs. It's a French military tube. This is what they look like. And we'll put this last tube in here, like this. Now we're going to save the rectifier tube socket for now because later on we've got several different rectifier tubes we're going to want to listen to and audition and see which one sounds the best. Let's go ahead and put these tube shields back on, and then we can service the grounding bus on the other side. Now what we're going to do is turn the amp over and service the grounding bus, which we saw was corroded in our initial visual inspection. In order to do this, we're going to have to remove these knobs and of course the pots and jacks in order to get to the grounding bus. To remove the knobs, we're going to take a ordinary jeweler's screwdriver, which I happen to have one right here. It's a little flathead screwdriver, and just simply take the knobs off. There's the last knob. Next, we're going to need a nut driver to remove the nuts on the pots. And I happen to have one right here. This one is a 1/2 inch, which is the correct size for these. These nuts just come right off. And of course the pots and the jacks are going to have a star washer in between them and the grounding bus. The star washer may be corroded. We're going to have to check for that. Of course, the face of the actual pot itself needs to be cleaned so that it makes good connection to the brass grounding bus. And of course, the next thing we do after we get this last nut off of there is we're going to want to take all of these components away. We can just take the little star washers out too while we're at it because they're going to fall off anyway. There's that channel. And then this is the controls from the other channel. It's absolutely amazing to see how much corrosion can form on one of these things in as little as 35 years. To clean it, we're going to use a brass bristle toothbrush. Now, you don't want to be brushing your teeth with these. They'll stain your teeth with the brass, but they're great for cleaning out grounding buses. We want to work this brass bristle brush in there and scrub all of this corrosion out of here. We want to make it nice and shiny around the points of physical contact of the pots and jacks. This is nice and shiny. Next, we want to clean the actual pots themselves. On the front edge, there is a surface that is going to touch the star washer, and we want to make sure that's nice and clean. We're going to work our way down the line and just do every one of these. This one here looks pretty clean already. The jacks as well, you want to clean these jacks up right around here. After we've done all of the jacks and pots all the way on down the line, we're going to want to check the star washers. These particular ones look good. These are nickel. These are pretty clean already. I see no visible corrosion. These are nickel star washers, and they were the factory standard for this particular amp. You want to check them anyway, though. If you find any star washers that are black anodized, they're non-original and should be avoided because the black anodized is non-conductive and therefore can cause bad grounds to be a problem in your amp. Next, what we're going to want to do is put everything back like it was. And to do this, it's going to work best if we line up the faceplate and the grounding bus and get them all lined up before we attempt to put anything back in. Now, one way we can do this is just to feel with a screwdriver, and this one is lined up already. There is a correct way and an incorrect way to put the input jacks back in. If you look at the jack closely, you'll notice one jack has a 1 meg resistor mounted across the jack, and the other jack does not have such a resistor. We want to mount it where the 1 meg resistor is the number 1 input, and the one without the 1 meg resistor would be the number 2 input. These should mount right in the mounting holes because everything's nice and lined up. We are going to need a nut to hold them in place. Okay, we've got the nuts back on. Next, we're going to install the pots. And here again, star washer on each pot. They just go right back in the same order they came out. Now look at here, a wire broke off. We'll have to get to that later. Of course, if a wire breaks off, you can always consult your schematic or layout to see where it goes. I have complete schematics in my first book. A desktop reference of hip vintage guitar amps. Matter of fact, the schematic and layout of this particular amp is in this book. We have the schematic here and the layout here. You can see that the wire that was broken simply attaches to the treble pot, which we can fix that later. The book has over 200 pages of schematics, over 500 pages total. Most of the schematics have been digitally scanned, cleaned up, and laser outputted. they're actually cleaner than the originals. Now what we want to do is finish up by putting the rest of the star washers on and putting the knobs back together. Now that we've gotten all of the pots reinstalled and the jacks and everything's up to snuff on this grounding bus, let's go ahead and repair the broken wire before we forget about it. Remember, it's right here, which is going to go right on this solder lug, but we're going to need to desolder the part that we're going to later solder, and to do this we're going to use a solder sucker. And we heat from one side and suck it out. And what we have is a clean place to solder our wire. Now I'm going to take the wire and make a nice physical connection. By the way, this wire here, you never have to strip it. This is pushback wire. You just push it back a little bit here. And when you finish, you can pull it back to where you need it to be. And we take this, it goes right in the little solder lug, and we're going to make a real nice mechanical connection like so. We're going to solder it by heating one side and applying solder to the other. That way we are assured of a good connection, good hot solder joint. There we go. Now we're going to do the cap job. We're going to start with the filter caps on the back here. These are 16 at 450. I have some 16 at 475s. These are the standard value. In fact, these are Sprague 16 at 475s. And what we're going to do is we're going to look at this and notice all of these are in the same polarity. You can see the positives are all on the same end and the negatives are also on the same end. All of these are the same values. They're all 16 at 450. Sometimes they will not be the same value, and sometimes they may not all be in the same direction. So this is something you want to look at and make sure of. What we're going to do is take these out. We're going to cut off all of the positives here, and we're going to remove the old solder using the same technique with the solder sucker. You have to cock these every time, of course. We may have to go back over these a time or two also to get all the solder out. Yeah, these have quite a bit of solder in these lugs. Might take a while to get this all out. Sometimes it works better if you take the old wire out first. If this don't work, you just have to get a bigger hammer. Yeah, we're going to go back and suck some more solder out of these. Now this one here, that was not going to come out because it goes over to here. So let's get the rest of the solder out of here. There's still a little bit in here. Looks like my solder tip is starting to get a little dirty. That's why I keep a wet sponge. Keep that thing nice and clean. Now we're going to remove the caps on the other side. Now we'll use the solder sucker to get the rest of the solder out. There we go. Look at here. Sometimes your solder sucker will do this. When that happens, take it out, make sure it's clean. There we go. Now we're ready. Some of these wires that are sticking out of here go underneath the board, so I wouldn't recommend trying to take them out unless if they come out easily. Like I can see this one right here is going to come out real easily. You go ahead and take it out. But if they're in there hard, like some of these other ones, they're under the board and they're not going to want to come out. So just don't even attempt it. What we're going to do is take the caps and cut the lead lengths on them so that they'll all fit. This one's going to need to be cut about here, and we'll put that in there to see about where the other cut needs to be. And you can't see it on this side, but I can see that it needs to be right there. So there we have it. They're all going to be the same length, so you can use this one as a guide to pre-cut the others, as I've done here. These are all pre-cut. We're going to put them in the correct polarity. They're all going to be identical. They should just fit right in the holes. Of course, we'll come back later and we're going to solder all of them. Now see here, you've got about 1, 2, 3, plus the resistor, plus this, 5 things going in one hole. We're probably going to have to heat that hole up a little bit to get that one to do right. And we'll come back in a minute on that. Set that one there. We got one more. There we go. Okay, now we're going to solder them. We'll start by just heating it up. Get it kind of hot first. I like to do one side at a time. There's a nice joint. Uh-oh, it moved. I'm going to go recook that in a minute. You don't want your work to move while the solder's drying. You want it to stay perfectly still so that you can get a good, nice bond. Put a little solder here. You notice I'm not putting the solder on the gun. It's very important not to do that. Now on this one, we're going to have to heat it up a little bit because that has so many wires going in that eyelet. We're going to have to work with this one to get it to go in there easily. There we go. There we go. Right on down the line here. Also, you can regulate your heat by the angle of your solder pencil. If you want the work to get hotter, you manipulate it where there's more surface area. If it's getting too hot, then you change it to more of this angle here where you have less heat transfer. More surface area, more heat. Less surface area, less heat. Now let's recook this one over here because it did move while it was drying. You can see the solder is real shiny. When it gets hot enough, it's real shiny. If it's real dull looking, it didn't get hot enough. Now we'll solder the other side. This is the negative sides. And I think what we'll do is we'll take these and poke them down in there real good to start off with. Make sure we've got a good mechanical connection here. Using these needle nose pliers so we can pull some of this lead length out of here and get them down there nice and tight. I can see this one's probably going to need to be heated up a little bit. We've got a couple of other wires in there, and we'll heat this up so we can poke that capacitor lead down in there nicely. Get it in there deep. There we go, and then we have this one here. There we go. That last one's a done deal. Now we're going to want to solder these. We're just going to heat up these joints nicely and put the solder not on the iron, but on the actual work. We do want to make sure that the solder dries without any movement. So that's the reason why I didn't do this one and then this one, this one, and this one. I did them all on one side first. But when I come back to this one, I know that this joint is well dried. If you're getting trouble with heat transfer, you can just put a little bit of solder on the tip of your pencil and it'll help with the heat transfer because you'll increase the surface area. You just have to be patient. The trick here is to do it good, not fast. If your pencil's not heating up properly, sometimes you need to check the tip Make sure to get that tip nice and tight. There, all done with the filter caps. Now we're going to take a moment to inspect our work. This is real important because if you get these polarities wrong, when you turn your amp on, you're going to have an exploding cap on your hands. And it makes an awful smell, and no one likes to see smoke coming out of their amps. We see that we've got